There are a couple hints that you need to know when you're watching these videos. Hint number one is to use focused watching. You can't watch this like you'd watch the news off in the background. You have to really be focused in on what you're doing and what you're learning, pretending almost like you're at a lecture. Number two, watch with a pencil. You have to be writing down on your notes the stuff that I'm doing on the screen, just like you would in a lecture. Again, try to make it just as much like a lecture as you can. Number three is pause the video to do calculations. A lot of times in class, I would just give you wait time while you stopped and did the calculations that I'm doing. You have to do that for yourself here. You have to pause the video so that you can write down the things that are on the screen. And if you follow those three instructions, it should get you started. We use exponential functions a lot in other areas besides mathematics. They're used a lot in economics. Anytime you have an investment or interest, you're using an exponential function. Also, when you figure gas prices, they have risen exponentially over time. The national debt has increased exponentially. So those are some examples in economics. Also, whenever you talk about population growth, whether it be in chemistry or biology, when you talk about a cell that divides and multiplies, you're talking about exponential growth. Also, a lot of instances in social studies use exponential growth, like populations, world populations, U.S. populations. So those are some places where we use exponential functions in other areas. An exponential function is anything that has the form f of x equals b to the x, where b is a positive number and not 1. So the b can be a whole number, like 3 to the x, or a fraction, like 1/2 to the x power, or a decimal, like 1.5 to the x power. Notice in all of these that the x is in the exponent. B cannot be a negative number, so you cannot have -4 to the x power. B can also not be 1, so you cannot have 1 to the x power. We're going to spend some time talking about evaluating exponential functions, and what that means, for example, if we know that f of x is 3 to the x, to find f of 2, we'll simply replace the x with a 2. So we would do 3 to the 2nd power. And for f of -5, we would do 3 to the -5th power. And for f of square root of 2, we would do 3 to the square root of 2 power. Then we do have one special exponential function that you see quite a bit especially in science classes, called e to the x. F of x equals e to the x. It's called the natural exponential function. It has its own special key on the calculator, which I'll show you in a minute. E is actually just a number. It's approximately equal to 2.718, so on. You can see it there. So when you are evaluating this on a calculator, to find f of 2, you'd simply find e to the 2nd power. To find f of 0.5, you would do e to the 0.5 power. And to find f of -1, you would do e to the -1 power. If you don't have a calculator that has an e to the x button, you can also use this numerical approximation for e. So for example, if we wanted to find f of 2, we would want to do e to the 2nd power. Well, we know that e is 2.71-ish, So we can just type into our calculator 2.718 or whatever approximation you want to use, and then use the to the button and put in 2. So to evaluate this function, to evaluate f of 1, we need to sub 1 in for the x in our equation. And to evaluate f of negative 1.5, you just put 1.5 in for x into the equation. And you can either do this by hand and evaluate these to get 3e to the 1 and 3e to the negative 4, and then evaluate on a calculator. Or you can just type this whole statement into a calculator to get your numerical value for the function. The next thing we're going to do is look at the graph of an exponential function. Exponential functions all look similar. They start out increasing very slowly, and then they increase more rapidly as time goes on. So the first thing I want you to do is find the y values for the given x values. That means put the x values in, use your calculator to get y values out for these times. So stop the video right now and get y values and then graph. So once you graph, your y values are there, and this is your graph. And notice that if we kind of connect our dots, we start out increasing very slowly, and then as we go, we start increasing more rapidly and more rapidly. And that's what an exponential function looks like. This is actually a doubling function because it doubles each time. So the last thing I want to talk about is the difference between an exponential function and a function with an exponent in it. When there's an x in the exponent, that's how you know that it's exponential. That's the only way something can be exponential. When you just have an exponent in your function, it doesn't make it exponential. The x has to be up there in the exponent in order to be exponential. So this one right here, this is a quadratic function, and this one is a cubic function. And that's our notes. Thank you.